Optical Character Recognition using Tesseract Engine. Abstract. The technology of Optical Character Recognition, OCR, was used to transform printed text into editable text. In a variety of applications, OCR is a very helpful and popular approach. Text preparation and segmentation techniques can influence OCR accuracy. Because of the image's varying size, style, orientation, and intricate backdrop, retrieving text from it might be challenging at times. We begin by discussing the Optical Character Recognition, OCR, technology, its design, and the experimental results of OCR conducted by Tesseract on medical data images. We end this work with a comparison of this tool with other detection methods in order to improve detection accuracy. Keywords: OCR, Tesseract, PHP, OpenCV, Python. Introduction. Text recognition in a natural environment with no constraints is a difficult computer vision and machine learning issue. Optical character recognition, OCR, systems have traditionally focused on retrieving text from scanned documents. Due to visual distortions such as distortion, occlusions, directional blur, crowded backgrounds, or various perspectives, obtaining text from natural situations is more difficult. OCR systems consist of a hardware and software combination that converts physical documents into machine-readable text. Text is copied or read using hardware such as an optical scanner or dedicated circuit board, while further processing is usually handled by software. Artificial intelligence may also be used in software to achieve more complex techniques of intelligent character identification, such as detecting languages or handwriting styles. The most typical application of OCR is to convert hard copy legal or historical documents into PDFs. Users may modify, format, and search the document as if it were written with a word processor after it is saved as a soft copy. Tesseract is a free and open source OCR engine created by HP between 1984 and 1994. It emerged out of nowhere for the 1995 UNLV annual test of OCR accuracy, shined brightly with its results, and then vanished behind the same veil of secrecy that it had been constructed under. Details of the architecture and algorithms may now be shared for the first time. Tesseract started as a PhD research project at HP Labs in Bristol, and it grew in popularity as a potential software and/or hardware add-on for HP's flatbed scanners. The fact that commercial OCR engines were in their infancy at the time offered motivation, as they failed terribly on anything but the finest quality paper. To execute as precisely as feasible, OCR usually comprises of multiple sub-processes. Literature review. The conversion of scanned or printed text images, as well as handwritten text, into editable text for further processing is known as optical character recognition, OCR. This technique enables the system to identify text on its own. Fink et al. 1 discuss different OCR systems based on Markov models in a survey article. The many processes of OCR are described in depth. Details about the Markov model for handwritten characters are provided in this publication. There are many different types of OCR software on the market nowadays, such as desktop OCR, server OCR, web OCR, and so on. Any OCR tool's accuracy rate ranges from 71% to 98%. There are a lot of OCR programs out there right now, but only a few of them are open source and free. One of the open source and free OCR tools is Tesseract 2. Because it is developed in C++, it is platform agnostic. It may be utilized as a dynamic link library in other applications, DLL. As a result, it may be readily included as a reference in the form of a DLL in other applications to leverage Tesseract's capabilities. For Devanagari characters, this system achieves 99.18% accuracy, while for Bangla characters, it achieves 98.86% accuracy. Bilal et al. 3 proposed a thresholding technique and dynamic windows for local binarization of document pictures. The method presented in 4 is intended to correct the text extracted from camera-captured pictures. Thomas D. Slater CTAL5 presented an OCR system for detecting handwritten characters and transforming them to digital text. Apurva A. Desai's 6 method recognizes Gujarati handwritten numerals using an artificial neural network, and this algorithm can recognize Gujarati digits with an accuracy of 82% on average. HP published Tesseract as open source in late 2005. It may now be found at 7. It is quite portable. It is more concerned with giving less rejection than with accuracy. At the moment, just the command basic version is accessible. Tesseract version 3.01 is now available for download and usage. It was never utilized by HP. Google now develops and maintains it. It supports a number of languages. Text recognition in an unrestricted natural environment is a difficult challenge for computer vision and machine learning. Traditional optical character recognition, OCR, systems are primarily concerned with extracting text from scanned documents. Natural scene text acquisition is more difficult. Owing to visual abnormalities such as distortion, occlusions, directional blur, crowded backgrounds, or various perspectives. Despite these challenges, recent advancements in deep learning have resulted in substantial improvement on this issue. 8-13. Materials and methods. OCR systems use a variety of approaches, but most focus on one letter, phrase, or block of text at a time. After that, one of two methods is used to identify the characters. Pattern recognition. OCR systems are fed samples of text in a variety of fonts and formats, which are then compared and recognized in scanned documents. Feature detection. To recognize characters in a scanned document, OCR systems use rules based on the attributes of a given letter or number. For example, the number of angled lines, crossing lines, or curves in a character might be used as a comparison feature. Figure 1, Schematic diagram of model. Techniques of OCR. Pre-processing. OCR software often pre-processes images to improve the chances of successful recognition. Askew. If the document was not aligned properly when scanned, it may need to be tilted a few degrees clockwise or counterclockwise in order to make lines of text perfectly horizontal or vertical. Despeckle. Remove positive and negative spots called specks, smoothing edges. Binarization. Convert an image from color or grayscale to black and white. Line removal. Cleans up non-glyph boxes and lines. Normalize aspect ratio and scale. Text recognition. Two basic types of core OCR algorithm. Matrix matching involves comparing an image to a stored glyph on a pixel-by-pixel basis. It is also known as pattern matching, pattern recognition, or image correlation. This relies on the input glyph being correctly isolated from the rest of the image, and on the stored glyph being in a similar font and at the same scale. Feature extraction decomposes glyphs into features like lines, closed loops, line direction, and line intersections. PST processing. OCR accuracy can be increased if the output is constrained by a lexicon, a list of words that are allowed to occur in a document. Tesseract uses its dictionary to influence the character segmentation step, for improved accuracy. Near-neighbor analysis can make use of CO occurrence frequencies to correct errors, by noting that certain words are often seen together. Knowledge of the grammar of the language being scanned can also help determine if a word is likely to be a verb or a noun, for example, allowing greater accuracy. The Levenshtein distance algorithm has also been used in OCR post-processing to further optimize results from an OCR API. Application-specific optimizations. The major OCR technology providers began to tweak OCR systems to deal more efficiently with specific types of input. Beyond an application-specific lexicon, better performance may be had by taking into account business rules, standard expression, or rich information contained in color images. This strategy is called application-oriented OCR or customized OCR, and has been applied to OCR of license plates, invoices, screenshots, ID cards, driver licenses, and automobile manufacturing. Applications of OCR. OCR engines have been developed into many kinds of domain-specific OCR applications, such as receipt OCR, invoice OCR, check OCR, legal billing document OCR. Methods to train model. Tesseract is a free and open source text recognition OCR engine distributed under the Apache 2.0 license. It may be used directly or via an API for programmers to extract written text from pictures. It supports a large number of languages. Tesseract does not have a graphical user interface, GUI, although there are numerous accessible from the 3RD Party website. Tesseract is compatible with a wide range of programming languages and frameworks via wrappers, which may be found here. It may be used in conjunction with the existing layout analysis to recognize text inside a big document, or with an external text detector to recognize text from an image of a single text line. Pillow and Lepto-NICA imaging libraries, including JPEG, PNG, GIF, BMP, TIFF, and others. Following command is used to consit OCR engine ptesseract.cmd equals rc /program files /tesseract OCR /tesseract.exe. OpenCV, Open Source Computer Vision Library, is an open source computer vision and machine learning software library. OpenCV was built to provide a common infrastructure for computer vision applications and to accelerate the use of machine perception in the commercial products. Being a BSD licensed product, OpenCV makes it easy for businesses to utilize and modify the code. The library has more than 2,500 optimized algorithms, which includes a comprehensive set of both classic and state-of-the-art computer vision and machine learning algorithms. These algorithms can be used to detect and recognize faces, identify objects, classify human actions in videos, track camera movements, track moving objects, extract 3D models of objects, produce 3D point clouds from stereo cameras, stitch images together to produce a high-resolution image of an entire scene, find similar images from an image database, remove red eyes from images taken using Flash, follow eye movements, recognize scenery, and establish markers to overlay it with augmented reality, etc. OpenCV has more than 47,000 people of user community and estimated number of downloads exceeding 18 million. The library is used extensively in companies, research groups, and by governmental bodies. Ptesseract. Ptesseract is a Python wrapper for the Tesseract OCR engine. It can also be used as a standalone Tesseract invocation script because it can read all image types supported by the required installations. Pip install OpenPython pip install ptesseract. OpenCV package is used to read an image and perform certain image processing techniques. Python Tesseract is a wrapper for Google's Tesseract OCR engine which is used to recognize text from images. Algorithmic review. To begin with, given input image can be any image e.g., book page, cards, digital IMGs. In Figure 4 sample input images is book page in digital format. Figure 4, sample input image. When image is given as an input image processing techniques are applied. In first step thresholding is performed moreover, after thresholding grayscaling is done. For thresholding and grayscale following commands are used. Adaptive_threshold equals CV2.adaptive threshold, gray, 255, CV2.adaptive_thresh_Gaussian_C, CV2.thresh_binary, 85, 11. 6. Conclusion and future scope. To sum up, developed models is able to detect and extract text from images. However, accuracy is maximum for Tesseract engine, moreover output is saved in text file. Tesseract performs well when document images follow the next guidelines: clean segmentation of the foreground text from background, horizontally aligned and scaled appropriately, high quality image without blurriness and noise. The model's key drawback is the blur or light images. In order to improve its accuracy, our future approach will be based on gathering more enhanced techniques from various sources and improving the proposed image processing algorithm.